Before there was Earth, before the stars were born, before even light itself existed, there were only two simple states, two primal patterns shaping the first code of existence. $4 billion years ago, Earth was silent. No oceans, no forests, no life. Only fires, stone, and chaos. But then, something extraordinary happened. A single spark, and the universe was never the same. Burning magma to crashing meteors, our planet transformed in ways we are only beginning to understand. And somewhere, hidden within this chaos, the story of life was waiting to unfold. How did lifeless atoms become living cells? How did simple molecules learn to copy themselves, to evolve, to think, to dream? Was it just chemistry, or something deeper, hidden in the quantum fabric of reality? $4.5 billion years ago, there was no blue planet, no oceans, no forests, no life, only chaos, only fire, and silence. Before Earth, there was chaos. A massive star far older than our sun ended its life in a cataclysmic supernova. It scattered stardust across the void, forging the elements of life itself. From these ashes, a new star was born. Our sun. It pulled gas and dust into its fiery heart. Around it, fragments of rock and ice collided violently, forming 8 worlds. Among them, a small unstable sphere destined to become home. Earth's birth was violent. Its surface, an endless ocean of fire. Giant meteors crashed down endlessly, melting rock into rivers of magma. Lightning cracked through a toxic atmosphere filled with methane, ammonia, and carbon dioxide. There was no air to breathe, no oceans, no land, just fire, thunder, and chaos. And then, something extraordinary happened. From the frozen edges of the solar system, comets and asteroids brought water to Earth. For millions of years, ice crashed into molten rock until steam filled the skies. Clouds formed, rains fell, and the first oceans were born. For the first time, our planet could breathe. Beneath the dark oceans, hydrothermal vents spewed heat and minerals into the depths. Simple molecules danced in a chemical storm until lightning, heat, and time triggered something extraordinary. Chains of RNA, the first carriers of information, formed inside microscopic bubbles. From chaos, chemistry. From chemistry, life. But what if life didn't just happen by chance? At the quantum level, particles exist in a strange dance of possibilities. They communicate across vast distances instantly, a phenomenon scientists call quantum entanglement. Every atom in your body once danced inside the heart of an ancient star, and perhaps every particle remembers where it came from. From stardust we came, and to the stars we will return. But Earth is only the beginning. Before the stars, before time itself, there were two smallest real particles, the foundation of everything. Imagine everything you see, every star, every ocean, every thought, built from just two states. One holds structure, one drives change, like binary codes in a computer. One is stability, the other variation. Alone, they are nothing. Together, they create infinite possibilities. From this moment, we call them Aru and Numa. Aru represents stability, like 0 in a binary code. Numa represents change, like 1. Together, they are the universal binary, shaping everything we know. Like binary codes in a computer, Aru and Numa write the universe itself. In a computer, every image, sound, and motion is just combinations of 0 and 1. The universe works the same way, but its codes are real. Aru and Numa are the binary of existence. There is no third particle. Every atom, every molecule, every living thing is written by the same two building blocks. Aru and Numa, from just two smallest real particles, arise the laws of existence, not written, not imposed, but expressed by their interaction. Every atom inherits its traits from this cosmic binary. Some atoms stay stable, others become restless, seeking new bonds. This diversity of nature creates absolute laws, guiding every reaction, every molecule, every life form. At the smallest scale, a hidden network emerges. Two identical particles share one state, mirroring each other instantly, no matter the distance. Imagine thousands of these particles, scattered across the universe, yet behaving as one. When one changes, all the others know, instantly. But entanglement isn't just connection, it is survival. Aru stabilizes atomic structures. Numa drives variation. Together, they assemble the building blocks of life. Proteins emerge. RNA learns to replicate. And LUCA carries the first blueprint of life, written by the dance of Aru and Numa. What if all life came from a single ancestor? Scientists call it LUCA. The last universal common ancestor, a fragile protocell, floating in a young ocean. What if LUCA wasn't random, but inevitable, written into the rules of reality itself? By two smallest real particles, Aru and Numa, LUCA survived because it learned to adapt, rearranging its molecular code, finding stability and flexibility in a chaotic young Earth. But why build complexity at all? Because without it, entropy rises fast, and everything dissolves into chaos. Aru holds structures together. Pneuma drives energy into change. Together, they create strategies for survival, slowing entropy, giving the universe more time to become alive. Aristotle once said, "The laws of nature are eternal." Newton wrote, "As if gravity has always existed." But what if everything we call laws today never existed in the beginning? What if these laws were written, not by gods, not by humans, but by something far older than the universe itself? Modern physics believes everything began from a single singularity, the Big Bang. One explosion, one space, one time. But if the Big Bang happened at only one point, why do billions of galaxies share almost the same energy patterns? To explain this, science introduced a new hypothesis, the multiverse, that perhaps there are countless universes beyond our own. But is that really the answer? And then there is the quantum world, where particles appear and vanish, as if without reason. Physics calls it uncertainty. Some believe every possibility happens at once, across infinite branching universes. But what if this so-called uncertainty is not random at all? What if what we see as chaos is actually code, a hidden language we have yet to read? Imagine, before the stars, before planets, before time itself, there was only one perfect symmetry, all particles, identical, all entangled, until something happened. The first separation, a single moment, where information, laws, and patterns were written for the very first time. Who triggered this event? What broke the first symmetry? And why does entanglement hold the key to our very existence? Episode 2, The First Spark, coming soon. Subscribe to QuantumVerse, and together we will explore where science meets the unknown.